We're live? Great. Good morning, ladies and gentlemen. Welcome to Asne PEP Electric Boat Competition 2025. My name is Daniel Erdogan. I will be your host today. We will have student interviews with student competitors, and we will be showing you live some of the boats racing. Thank you very much.
Hey everybody, I'm Jack with Flying Fitz Photography, and I have been brought here today by everybody knows the man himself, Mike Briscoe. He's not available right now. As you can probably guess, he's pretty busy. But we will be doing some interviews throughout the day. Daniel, who you just saw earlier, is going to be performing them. And you will be seeing some of these aerial shots. They may be accompanied by some pretty quick movements. Do not mind those, because we are recording and making a video that will be posted after PEP is actually completed, and that will be really nice, color coded, really good looking footage that everybody can look at. So don't stress if the quality of the stream gets a little choppy or anything like that. Anyway, that's it. I'm looking forward to getting you the content that you're excited for, and I'll see you soon.
Welcome back. My name is Daniel again. I have two students here that are currently actively racing. Please introduce yourself and what college you're with.
I'm Jacob DiFrancesco. I'm the team lead for the University of Buffalo.
I'm Thomas Turner. I'm on the Texas A&M electric boat team.
Cool. So I have a couple questions for you gentlemen here. What inspired you to join the Asne PEP competition?
I think it's just a very unique opportunity to experiment with electric crafts, especially since the world is trying to transition more to electrified vehicles. I think it's very important for commercial and defense uses, especially as the military wants to do more autonomous drones and things of that nature.
Cool. What about you?
I think it's really just a great opportunity for us students to get to work with our hands and really learn naval architecture skills as well as other skills that we might not learn, like with electrical adaptations with the battery systems and motors.
Cool. Awesome. So Buffalo is currently racing. We will switch to Buffalo and we'll talk about their boats now. All right, so we're here with Buffalo. Can you talk about what kind of hull you chose for this competition, and are you running manned or unmanned?
This is the unmanned boat. We have our controller on one of the naval vessels out in the water. Our hull is a V-shaped monohull. This is different from last year's, which was a catamaran. Catamarans tend to be more stable but not quite as efficient on the water. And also with the wakes, they are a little more prone to capsizing. The monohull, on the other hand, is more prone to just cutting through the wakes and being able to maintain speed while going against the wake, which is really important for us.
What kind of propulsion system did you incorporate into your design?
It's a dual propulsion system, dual motor. We're using the Leopard Hobby 5692 motors with a 33-volt system. And we're expecting a speed of around like 15 to 20 miles an hour.
That's awesome. Well, how do you divide responsibilities within your team?
Basically, we just leverage each other's skills wherever we can. We have one guy who did electrical pretty much all by himself, and within 2 days he took 14 hours to solder together all of our connections for our batteries, things like that. We have another guy whose dad works with naval vessels, and he knows a fair bit about hulls and what kind of design you'd be looking for while trying to race a boat.
Awesome. How was the team leading experience for you, would you say?
It was all right. I prefer to keep it pretty democratic and try to leverage everyone's skills wherever I can. Luckily, we have a pretty good group dynamic, so there hasn't been much need for any conflict resolution. And honestly, I feel like my job is more so dealing with a lot of the logistics and just making sure everyone's on track and that we just move towards our goal of building the fastest boat we can.
That's awesome. Did you run into any last-minute fixes or troubles before you raced today?
Not today, luckily. Everything's gone pretty smoothly with that. The only last-minute fix that could be considered last-minute was it occurred like a week before coming here, where we had a cavitation problem. There was too much air getting around the propeller, so we put cavitation plates over the propellers with JB Weld just to help improve the efficiency of it.
Okay, and one of my final questions here is, what was the hardest part of building your boat?
Trying to kind of just install things into the hull, I feel like. Learning to build the hull was a process because it was handmade using woven fiberglass and epoxy. But once we got it down, it really wasn't bad. It was more so just trying to put in our stringers and our electronics and trying to make sure things weren't at weird angles, because our motors kind of sit at...
Because it is electric and, you know.
Yeah, on our aluminum stringers we put electrical tape, because there actually was one instance where there was an electric arc running between one of the circuits and the stringers. So we put electrical tape on it to kind of prevent that from happening. And there's a physical kill switch in the boat that just breaks the circuit entirely, and there's a kill switch on our remote as well. And when we're doing dry tests on land, just running the propellers, we make sure no one's standing off to the sides, because if one of the propellers were to shatter, it would basically become shrapnel. So we make sure everyone's standing out of the line of fire when doing that.
That's awesome. What was your name again, and what school are you from?
Jacob D. Francesco, University of Buffalo.
Thank you, Jacob.
All right, thank you.
We will be back with Texas A&M as we find our boat. We are back with Texas A&M. What's your name and where are you from?
I am Thomas Turner. I'm from Texas A&M, so, but I'm from Texas as well, so
That's awesome.
nice.
That's awesome. So we're going to be talking about your boat here. Can you talk about what kind of hull design you went with?
We have a monohull. We initially designed it in CAD, and we were gonna have our wood pieces for the frame be laser cut. However, once we got there, we realized the wood we bought was a bit too thick, and we had to just cut it with a bandsaw because the laser cutter couldn't get through it. After that, we arranged it with staples to have a nice frame, all of it connected, and covered it in fiberglass and epoxy. And that's what's holding the hull together.
That's cool. Can you talk about the power system and drive system you incorporated into your boat?
Yep, so we have two motors. Each of them are connected to an Arincian drive, which allows us to connect both of our propellers as well as our rudders into one system. It just makes it really easy for us to navigate working with it, and we don't have to worry about a secondary system of rudders.
How do you think events like PEP help prepare students for careers in naval engineering or ocean engineering?
Yeah. So our A&M team, we are all ocean engineers except for one aerospace engineer. Ocean engineering is just marine engineering, so focusing on those offshore structures as well as onshore. This really prepares us for it with the naval architecture that most of us want to work on, as boat building is boat building. Not much different, just different scales. This really gives us the opportunity to realize what holes work, what doesn't work on the boat, as well as integrating electric systems, as that's what we're moving towards as a society.
This morning when I saw you guys had a large team. How do you manage a team like that? Or more so, how did your team divide responsibilities?
Our team divided responsibilities into 3 sub-teams. We had a modeling team that made the basic models as well as ran all of the analysis for the fluid flow across the boat. Then we had the construction team, which worked on building the hull and establishing a good frame for our electronics team to come in and put whatever they needed. And then, yeah, the last team would be the electronics. They worked with the ESCs, the batteries, the motors, as well as setting the pumps up so that we could water cool everything in the boat.
That's awesome. So you spoke about some simulation. Can you dive more into that, please?
I believe we used ANSYS for the simulation. It was just for basic fluid flow across the boat, just to see what our resistance and drag coefficients would be. We basically really just needed it for the white paper.
What kind of challenges did you run to while building the boat, would you say?
Well, once we got our electronic system inside the boat and we started testing it, we realized that running the motors would quickly overheat them, which caused us to have to add ice to our water tanks that we're using for cooling, as well as after that we noticed, hey, our wires have started to melt here.
Whoa.
So we had to change the gauge of wire, and we added those second set of batteries. That way we could drop the current running through those wires.
And my last question here is, how did your qualifications go yesterday?
Qualification went really well yesterday. We got the boat working, and then we got in the water, and it went out, went back. It didn't get caught in the wind too bad, but today looking a little rougher.
Awesome. Well, thank you very much. So when you're repairing on site, why is that important as an engineer to find quick fixes to problems you're running on the field?
It's an important thing to do as an engineer, to be able to adapt to those situations and repair on site so we can get a working product out there to perform whatever task it needs to do in a timely manner. So right now they're working on the boat. It looks like they're working with the motor system, so hopefully they're just having to set up the different drives properly and get that up and running so we can get it going for the race.
Thank you. And your name and school again, please?
I'm Thomas Turner from Texas A&M.
Awesome. Thank you, Thomas. So we're back again with another student. Please introduce.
Yeah, definitely. So we have a grad student who's now since moved on and gotten his PhD, who's been building these boats for a long time, and he's really into keeping some of the realism and some of the accuracy. So some of our old boats, even looking at it, they have internal structures. One of them has a movie room with a working projector in it. We have some different things, some unique things going on. So, you know, we've had a couple people say if it was a beauty contest, you guys would have won immediately. But yeah,
It definitely caught my eye.
A lot goes into it. So our boats are fully made out of popsicle sticks, epoxy, and fiberglass.
Wow.
And so it's a lot of free-form design and cutting popsicle sticks the right way and making sure things line up and look good and feel good. And yeah, it's pretty nice. It's cheap material, so we don't feel super stressed out when we're working with it. And if we need to make a modification mid-phase and mid-build phase, that's not that big of a deal.
Yeah, we spoke about some performance, some about 20 miles an hour. Could you go into that a little more? What kind of drive system you have and what kind of motors you got?
Definitely. So when we were first starting out in the planning phase for this boat, it was before the competition had shifted from 5 miles, basically a 5-mile time trial, to 2 miles with a payload. So this boat was designed and tested at 20 miles an hour, up to 12 miles of range. When we shifted to this new competition design, we ended up removing some of our battery weight and shifting around where our payload placement was. Currently, we have quad motors inside the boat, and they are around 1.3 horsepower each, and we run dual batteries. They are 6S 22 volt and 20 amp hours each. So we were still seeing well over 3/4 of our battery left after the race, so we probably could have scaled back even further from where we were, but we're happy with the performance. We definitely had some issues with payload shifting and battery shifting, but other than that, I mean, we did 2 miles in a little over 7 minutes, so it keeps on pace with the 20 miles an hour we were expecting, and we're happy.
So you have a really well-rounded off boat. Can you talk about kind of your team size and how you guys divide responsibility to really finish a boat the way you guys have?
Definitely. So a big part of it has come down to sort of building out that core group and our core competencies within the group. So we have one grad student, Shubham, who's incredibly good at design and the design aspects of things and how to make organic whole forms. We have another student, Leo, who's very good at a lot of the technical documentation and things that go along with that. Ashley, incredibly good at CFD. I kind of jump between all the areas and do system integration and parts ordering and a lot of the logistics work with it. We still are in contact with that old grad student occasionally on more of a consulting basis, and he works with us to make sure that we are keeping things like within his plan and we understand how he had things laid out. And then we've also been working with, we got our first corporate sponsorship this year with a company based out of Hawaii with an office in Rhode Island called Pacmar Technologies. So they've been helping us a decent amount too with CFD, and we needed some last minute parts printed. It's really been an all hands on deck effort from everyone. The whole Navy STEM team at URI has been helping us, parts ordering, logistics, whatever it might be.
That's really cool. So you spoke about CFD. So can you go into some of the modeling and so simulations you had to do to on this boat?
Definitely. So the boat was originally modeled by our grad student in Rhino, and then we shifted from Rhino into SolidWorks to do flow sim on the boat. We ended up losing all of our CFD results accidentally. We tried rerunning in ANSYS, but we were running into some issues with watertight surfaces and other issues. So actually, the night the white paper was due, we ended up bouncing back to flow sim, and in like 45 minutes, we got some decent looking results. So that's what we ended up going with for CFD. Modeling, we've also been trying Blender this year for some more organic hull forms and getting some more unique shapes and things associated with them. So the grad student Shubham is incredibly good with Blender, and he's very quick at making alterations. It's been really helpful for doing small scale tests and small scale models and things like that.
Yeah, Blender, I messed around with Blender. It's pretty cool. So you said you had to do some last minute like simulations right before the white paper was due. What else did you have to do last minute that you ran into, like troubles or issues like that you didn't expect you'd run into?
Yeah, so the main one prior to arriving here was that payload placement and having motor covers in place. Because we were using inboard motors, they're essentially drone motors, so the outside casing of them spins. So we had to create, in very last minute rush, make some motor covers so that the payload could sit as far forward as we needed it to. That ended up coming down to 3D printing some and then making some with the popsicle stick, fiberglass, epoxy mixture that we're kind of known for at this point. Once we were here at the competition, we ran into some electronics issues and some wiring problems. So it ended up resulting in us almost not qualifying. Ultimately, we did. A lot of troubleshooting, a lot of wiring, a lot of reworking day of. Bit of a headache, but you know, the whole team stayed persistent. We kept pushing and we got it done. So
That's awesome. And one of my last questions is, what inspired you to do PEP, and where do you see competitions like this taking engineering students?
yeah, sure. So actually, I met the PEP team for the first time at URI at an event for NIUVT, which is the National Institute of Undersea Vehicular Technology. They had brought some of their boats to showcase and show the engineers from Electric Boat in Newark and a couple of other places. And while I was there, a bunch of their grad students told me, hey, we're leaving, we need new people to come in. So I came in last year. It got me introduced to the club, got me up to the flow and the scheme of things, and then this year I've really taken over the club and sort of had my more leadership role in it, and yeah.
And where do you see the competitions like this taking engineering students?
Oh, so taking engineering students, this is definitely some of the most practical hands-on experience you're going to get at an engineering school. I would hate to say most classrooms aren't very practical for engineering, but most of them, just truthfully speaking, aren't. It doesn't get much closer than doing a last-minute diag, trying to, you know, get in these tiny crevices with a multimeter and realizing you hate how you design something. And, you know, it's very practical. It's very good experience and hands-on experience for an engineering student to get. It's incredibly, it's just invaluable, honestly, having this level of experience with working with your hands, working with tools, working in tight spaces, being part of a team, logistics. I mean, you touch on so many areas with this competition. It's really good for engineering students.
That's awesome. And to finish it off here, just your name again and what college you are, just right into the camera.
Yeah, sure. So I am Sam Miller, and I am from the University of Rhode Island in Kingston.
Awesome. Thank you, Sam.
Thank you.
Welcome back. We have another student here. Please introduce yourself and what college you're with.
Hi, I'm Nathan Vu. I'm from UVA.
That's awesome, Nathan. So could you talk about your boat a little bit? What kind of hull you chose to go with it today?
Yeah, so we decided to go with a 84-inch Bonzi hull. We primarily chose it because we were a little concerned about reliability. So by outsourcing a hull, we were able to make sure that we were resilient to those kinds of failures. And we decided to put it into a catamaran structure by having aluminum extrusion to connect the two hulls together.
That's awesome. Can you talk about what inspired you to join PEP?
Actually, so I did this as part of my senior capstone last year, and I was really excited to get a second chance because last year we actually caught on fire with one of our ESCs.
Yeah.
So I really wanted to give it a second shot, so that's why I'm out here again.
Can you talk about your drive system?
Yeah, so for our propulsion system, we're using some Castle 2028 motors. They're running about on a 12S system, which is about 50 volts, 300 amps, and so
Sorry, we're back. So we were talking about your drive system. Could you go back on that, please?
yeah, for our drive system, we're running some Castle 2028 motors. We're running them at 12S, which is about 50 volts, and they can go up to 300 amps, although we're not drawing that much. And then for our control system, we're using a Pixhawk flight controller.
That's cool. So you said you had dual motors?
Yes, we do have dual motor systems, one in each hull. So
That's awesome, man. So I got a couple more questions here. What was the hardest part of designing your electric boat, would you say?
one of the interesting things is that we really wanted to make the motors go faster, and so we've been working really hard to get our thermal cooling and basically connecting the two hulls together, because that was a big leap for us this year. Since last year we were doing only one hull, this year we're doing two hulls. So yeah.
That's awesome. So I have another question. You said you were running into some electrical issues last year where you may have caught fire. What preventions did you take this year so your boat could run more efficiency?
Yeah, so last year one of the big issues is that we unfortunately had a gearbox that ran a little too hot or something, and due to a variety of factors, that gearbox seized up, and so our ESC kept trying to send power to the motor, and that motor just ate through a ton of current all at once, and that caused our ESC to pop and basically, have a little bit of electrical fire. Fortunately, no one was hurt, and it was put out pretty quick.
That's awesome. So this year you chose a new gearbox, or what did you do to prevent that? Sorry.
Yeah, so this year we decided to shift away because last year we were using solid shafts. We transitioned to using flexible shafts so that we didn't have to use a gearbox or a spiral a helical coupler. And so that way we could avoid that mode of failure, and we also went into a bunch of other reliability improvements to our hull.
Yeah, I was seeing right before you guys raced, you guys were digging in the boat, and luckily the boat's nice and racing now. What kind of last-minute issues did you run into? Do you want to talk about that?
Yeah, so we were fine for qualifiers last year. So when we were running some static tests just before our heat, we were surprised that one of the ESCs wasn't receiving throttle messages. So we had because we have actually two flight controllers in our control box. One of them is for the actual control, and then we have a second test system where we're testing some GPS. And I think there was some kind of signal interference that caused us to lose throttle signal to one of our motors.
You said GPS, so this thing can run autonomously?
So yeah, we've been working hard on autonomous for the past month. One of our students, Jason, has done a lot of great work. He's been working on a ground station to basically correct for all the GPS errors, so we can get down to centimeter accuracy on our system. And then we're using the Pixhawk running ArduPilot to do waypoint autonomy, although we won't be demonstrating it.
Okay, so we're gonna come back to the camera here, so I could just talk with you in face.
Yeah.
Let's see here. So, could you talk about the size of your team and how you divided responsibilities?
Yeah. So our team this year is about 6 people. Unfortunately, 2 of them couldn't make it today due to travels, and 1 was sick. And so for our team, we basically have people working on the structures, the hardware side. I'm working on the electrical side, and I have 1 or 2 students working on the flight controller and control systems. And so that's basically how we've divided up our team for this year. Since we're a first-year club, we're a little bit small, but we were able to get the work done. And so next year, the up-and-coming underclassmen are really looking to expand the team and get some more members on board.
That's awesome. And you said you were running how many volts on your boat?
We're running about 50 volts.
So what kind of safety measures do you take to that's a lot of voltage. Voltage also allows current. What kind of safety measures do you take to ensure that the boat doesn't catch on fire again, or electrical safety really is my concern?
Yeah, we have 2 safety measures. We have some circuit breakers that that are rated for much smaller. So our motors can take, and ESCs can take up to 300, but our circuit breakers stop around 200. So they would trip before we theoretically reach that high amp. And we also have some fuses rated for 250 amps, just in case some spike hits it.
That's awesome. So with a team size of 6, how would you say the complexity of this build was? Was it hard to do some of the building aspects, or?
Yeah, I will say one of the nice things about having a small team is that we're really close together, and it's really easy to distribute work and work together. Since there's not too many people that you have to contact to integrate different work together. And so can we read the question?
So it's at a team size your size. What are some maybe drawbacks you ran into? We spoke about how it's nice that you can delegate work easily and it's easier to manage. But did you run into any issues where you couldn't make a deadline, let's say?
Yeah, I will say one of the things we really did struggle is some of the papers and video submissions. We had to basically rush them because our members had classes and stuff, so they might not have been available for couple days where it was really critical. And so that's one struggle of being a small team, is that you don't really have backups to be able to fill in for them, basically. But so we definitely skimped out on the paper and the video presentation that we were supposed to submit.
Yeah, that's awesome. And last thing here, could you tell your name and what college you're with, right into the camera?
Hi, yeah, I'm Nathan Vu, and I go to UVA School of Engineering.
That's awesome. Thank you, Vu.
Thank you so much.
We're back, and today we have Jake with us. Where are you from, Jake?
I'm from Maryland, Lutherville, Maryland.
What college do you go to?
Elon University.
That's awesome. So we're here to talk about your boat real quick. Let's start with, could you go into what kind of design choices you did to design your hull?
Yeah, so the hull is actually designed entirely out of sheets of aluminum. One of our group members, Jack, welded the whole thing together himself in our shop on campus. Originally, when we had our prototype, all we had was a jet sled as our hull. It was very rudimentary, but we had to make a quick decision about what we were going to do back in February, when we were getting ready to start actually testing it and all that stuff. So he welded the whole thing together. we place an order from Send Cut Send, have them cut and bend all the sheets together, and that's sort of how we ended up with our design. We didn't want to do steel though, because we knew it would corrode with the salt water, so that was the next best thing.
So I'm a little into welding myself. Aluminum is not an easy task to weld. So could you run into some? Could you tell us some of the issues you ran into, maybe welding the aluminum hull?
Lots of screaming fits from Jack. Honestly, there was multiple days where he just had to call it at a certain point and say, "I'm picking this up tomorrow," and it was especially hard for him because the boat itself was 5000 series aluminum. But all the clamps where we strap in like our battery box and payload are 3000 series, so that made it even harder to get the sort of result that he wanted. But at the end of the day, he just tack clamped them or tack welded them in for the clamps, so that's really all we needed for it to stay in place. So it was not too big of a deal there.
That's cool. So we're talking about the internals a minute ago and holding your battery. What drive system and what motors do you run on your boat?
We've got a Flip Sky brushless motor, and it came with the 3-bladed propeller already, and we're using a Flip Sky ESC as well. We took a lot of inspiration, I believe it's from UCF's boat last year. A lot of the initial research was just looking at other teams' white papers, because we're a first-time team. We were very new to this sort of thing. So we wanted to draw from other people's papers and just say, we know this works and we're going to try this out. Yeah, we're using an ESC and motor from Flip Sky, and we've got a Fly Sky controller, which was also used by a couple other teams last year. And it's been working great for us, but we still made sure to buy spares of everything just in case.
That's awesome. As a first-year student, could you tell me what size is your team and what kind of issues you may have ran into, depending on the size of your team?
Yeah, so we only had 4 people at the start of our fall semester, and that became 3 in our spring semester when a lot of the prototyping turned into finalizing our design. So that made for a lot of late days in our machine shop. A lot of issues that we ran into that had to turn into hours and hours of work, but it really paid off, I think. And we're hoping that next year their team, I don't know if it's going to be the same size, but they want to have them do a senior design project where they make this boat autonomous now next year, which is going to be awesome.
That sounds very cool. That's something I've tried myself. So you said a capstone project. Could you go into what made you want to do this as a capstone project?
It just really sounded way more interesting than all the other options, to be honest. There were other teams are doing gates for a tiger sanctuary, or environmental engineering, designing plans for erosion control. But this one, I was like, this is really like a mechanical challenge, I think. And so that's what made me, and it sounded cool, the fact that we'd be able to go to a competition. That's not something any other teams really get to do. So I put it down as my first choice, and luckily I got it. So
that's cool. Let's see here. So what kind of tests did you run on your boat before you came here, especially yesterday, because you had your qualifications? How did that go as well, if you want to talk about that?
Qualifications, I'm extremely surprised and happy that we qualified in the conditions yesterday. It was very windy. We'd only tested really on a lake on our campus, where we didn't really have conditions like that. But we had done things like distance tests to make sure it can actually go the 2 miles on one charge of our batteries, max speed test, cooling loop, because we actually have a cooling loop that goes through our battery box. And when we tested it, it brought the temperature of our box down by a significant amount compared to running it for an hour without it. So it was nice just to, once we were done actually getting all the systems working together, just tinkering and testing and figuring out what, that all of our design actually works pretty cohesively together, and what things might need to change as well.
So are you going to be in the team next year?
Unfortunately, I'm a senior, so I'm graduating. I won't be around, but I would love to at least tune into the live stream next year and see next year's senior design group get this boat going.
What kind of advice would you give to your next teammates or the next team that comes after you?
Something I've had a hard time grappling with is don't be afraid to fail. Don't be afraid to break something, even if you've spent hours and hours on one little part of your battery box, or you've been in the shop welding or machining some sort of part for your system. Testing and breaking things is good because that way it doesn't happen on competition day. So
yeah, that's I've competed 3 times, so I know breaking is basically the only way you learn sometimes.
Yeah.
Let's see here. How do you think an event like this, especially since you're a senior, an event like this looks on a resume and how it will help you in your engineering field?
I think it just is going to stand out a lot because it's very different from a lot of like the internships experiences that I've had, and even just any typical class that you'd have at a university. This is, something where the grade doesn't determine the quality of the work that you're doing. And I think it just really is going to stick out because you get to say, yeah, I went on this trip, went to a competition for my senior design project, and that's not something a lot of other teams get to do.
Yeah.
Show off their work in that way.
That's really cool.
Yeah.
And let's see, is there anything else you'd want to highlight about your boat?
We have a passenger today. It's Sasha's stuffed animal Cookie. I'm sure you can see it from the live stream, but he's strapped in at the top of our battery box, and other than that, I mean, it's pretty standard fare. We've got our battery box, and we actually, our professor made it so that we had to put an additional 15-pound weight in our boat as well, because that's the estimated weight of the autonomous components that they're adding next year. So extra little parameter for us to follow, which I think was helpful.
So with all these electronics in an aluminum boat, what kind of safety features did you design to prevent any arcing or any electrical issues?
We have a fuse in our box, luckily, and we also just used, we had to make sure we bought the right fittings for wires to come in and out of our box because it's designed to be waterproof. I believe it's like a Bud Industries box, and everything is clamped down, sealed in there nicely. But also used a lot of waterproofing sealant, glue. Basically, just want to make sure it's air and water tight so that nothing goes in or out besides the water coming in through our cooling loop.
All right. Well, that's all the questions I had. Real quick, could you look into the camera and tell me your name and what college you're from again?
I'm Jake Dyer, and I'm from Elon University.
Awesome. Thank you, Jake.
Yeah, no problem.
And we're back. And we're back. We have another student here with us.
Hello, I'm Ryan from Stony Brook University.
Awesome, Ryan. So I wanted to ask about your boat. What kind of hull design did you think of, or went into the thoughts that went into your hull design?
So for our unmanned hull, it's actually just a scaled down version of our manned hull. So that hull was designed a few years ago by some seniors at Stony Brook, and that was designed for optimal long distance and sprint performance. And it's a planing hull. It's a planing design.
It's a planing design. So what kind of motors do you have that's pushing that on plane?
We're using a direct drive brushless motor from an RC drone. It's about 55 millimeters in diameter and 3 or 4 kilowatts.
What kind of batteries are you using to run that?
We're using 2 sealed lead acid batteries in series.
And what's your drive system, would you say?
It's pretty much mostly 3D printed and easily upgradable and simple.
Is it just a single prop at the back, or?
Yeah, so using in the water, even though it was designed for air, but we found that it gave us good performance.
Oh, really? Okay. I mean, I fly FPV, so I'm guessing that's what you're referring to.
Yep.
A 5-inch diameter.
Yep, a 5-inch.
Wow, that actually performs well in water.
Yeah, it does.
That's great. So you said you Stony Brook built a manned team before. How long ago, and what kind of design was that?
Our manned team has been going to another competition called Solar Splash for I think over a decade by now, or a few decades actually. But this is our second year at PEP and our first year doing the unmanned event. So we're taking what we know from our manned experience and just shrinking that down to create a experimental and easily testable unmanned hull.
What's the difference between manned and unmanned for you, would you say? What kind of things carry over and what kind of things don't?
So the hull shape and the propulsion is direct drive instead of a traditional outboard like on most boats. And it's also pretty different construction-wise, so it's mostly 3D printed, so that saves us a lot of time and energy.
That's awesome. What size is the Stony Brook team, and how do you guys divide responsibilities?
Our team currently at PEP with us are 22 people.
Wow.
Our full team has almost 40, I believe.
Wow.
We've grown a lot in the past year, and it's been tricky to allocate all our resources to their best places, but we're working on it, and we're gonna be better.
That's awesome. And are there any specific parts of your boat you want to highlight right now?
For manned or unmanned?
For your unmanned boat that's competing right now.
So currently, with our design, it's a scaled version of our manned boat, but in the future, we want to consider using hydrofoils on both the manned and unmanned. So unmanned was designed to be a test platform for that.
Oh, that's really cool. All right. Well, one last thing, your name and what college you're from, and if you could just look right at the camera.
I'm Ryan from Stony Brook University.
Awesome. Thank you, Ryan.
Thank you very much.
We're back? Awesome.
All right.
So we have another student here. Please introduce yourself.
Hi, my name is Kai. I'm with UCF, specifically the Robotics Club of Central Florida at UCF.
Awesome.
Is that it? Yeah.
Yeah. All right. So we're interviewing you today because you have a completely 3D printed hull, and this is a little model.
This is a 1/20th size model of it. The actual boat is about 7 foot long and about 36-ish inches wide. Yeah, we're excited to put it in the water.
Awesome. So what went into designing your hull, and then what challenges did you face 3D printing the complete thing?
So designing the hull was like any other process. We started by looking at reference images with anything from traditional sailing boats to racing boats. We kind of, our major inspiration was race boats that had kind of like a pontoon but single hull design. So you can see the hull itself is actually completely conjoined as like a solid piece, but it's a technically a catamaran because there's two distinctly separate hulls. We went with that design partially because it looks cool, another part because slight simulations showed that it actually performs way better than if we had just two hulls and then like a floating midsection. We just needed a place to put our electrical section, which coincidentally having a midsection would help with.
That's awesome. So you said you 3D printed the whole thing. What kind of what kind of troubles did you run into with that, if any?
So a major problem was picking the material, which we ended up going with PETG, just because it's a lot more durable than PLA with PLA's no special equipment needed, such as like carbon filters, fume extractors, etc. So it's way more durable than PLA, and it's almost as easy to print as PLA. But one of the major issues is just printer maintenance, because we have two Neptune Maxes going constantly for a month to print the boat.
Wow.
So it's essentially after every part we have to level the bed, check the wheels, check the belts, tension the belts, check the heat bed, recalibrate it, level it. And that whole process takes like maybe 3 hours to do after each print. The boat itself is divided into two 7-section. The two left and right hull, the midsection, both of the hulls are divided into 7 sections, which has 2 parts. The parts are what's actually being printed.
Awesome.
So essentially, we had to. Each part takes about like 2 days to print. So after 2 days of non-stop printing and replacing filament, we have to do that 3-hour recalibration process.
That's yeah. I mean, I 3D print myself, so I know how intensive that maintenance can get. So you spoke about some modeling and simulation. What kind of simulations did you do? I guess in designing your hull.
So the very obvious first simulation we ever did was a buoyancy and center of gravity test, which showed that it actually performs relatively well. It's insanely buoyant because, well, the whole thing's plastic. The second simulation that came up with that is what's essentially like drag or like hydrodynamic simulations, which is just what we ran was SolidWorks simulations. Not the best, but it works for its intended purpose, and it showed some pretty great results with our boat not sinking, or well, it does sink in. It sinks in the back, rises in the front, which is what we want to see. And we did observe that in our test runs, so it's pretty nice.
That's cool. And my last question here is, what size is your team? You know, you're printing a lot of things. You're running around, I guess, maintaining the printer, and there's also assembling all those printed parts. What kind of team do you have, and how do you divide tasks to your teammates?
Yep. So essentially, we had we have 8 members, split into 3 teams, which is just the hardware team, the electrical team, and then the we had a printing team, which is basically what I was in charge of. So the printing team obviously handled anything from printer maintenance to filament replacement, etc., etc. The hardware team is anything like aluminum extrusion. We have an endoskeleton. They handle that, which is just aluminum extrusions, T-nuts, bolts. The electrical team did all of our batteries, wiring, etc. Because this competition is kind of like scheduled really, I don't want to say late into the semester, because like finals for us is like next week. So a bunch of the team members couldn't come because we emphasize academics, but we did end up having the leads from all 3 teams come. So me for printing, they're getting lunch, but it's Matthew for the electrical and Dwight for the hardware.
Yeah, that's cool. And sorry, I said it was my last question, but this is my real last question. 3D printing everything. What issues did you run into just building the boat in general?
So we half expected this and half did not. But after even 2 days of printing, the tolerances on our printers started shifting ever so slightly. So we have to last minute compensate for about like half an inch of tolerance differences between almost every printed sections, because 2 parts went together perfectly fine, but each section didn't perfectly go into another section. So we had to ditch the idea of a hole and dowel to like put everything together. We ended up shoving in an aluminum extrusion bar through all the sections to line them up to the extrusion bar, because that's what we declared as our mid or center point. And the gaps that were on those were really bad. We had to sand each section, the joining point. We used JB weld and then a plastic welder to hold it all in place. And then we used body filler to try to smooth out the gap.
No. Well, thank you for interviewing with me today. One last thing, your name and what school you're from again into the camera.
Okay. Kai?
See you soon. Hello. Hi everybody, it's me, Jack again. I am letting you know that we are done with lunch. There's still some people eating, but we're going to continue on with PEP. If you have any questions, feel free to throw it in chat. We have Daniel here who's going to be answering them. But in the meantime, I hope you look forward to the content that's going to be up here again. Yeah. Why are you guys talking about Reggie Rock so much? Talk soon. If you can hear me, Reggie Rock, if you want to come up here for an interview now, you're welcome to. Hello, we are performing a test for the ceremony. Test, test, test. Test, 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 test. Test, 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 test. Test, 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 test. We are at the Jeep, at the Subaru. We are almost at the table, over the wall. We're at the table in 3, 2, 1. We're at the table. Test, 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 test. Test, test, test. At the snacks. Snacks, 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 snacks. Turning around. Test. At the table with the trophies. Trophy, 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 trophy. Hello, everybody. I am here with the trophies. Test, 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 test. Walking back. At snacks? Okay. This has been your certified Flying Fitz test. It's on? All right, this is test number 2. Test number 2 with cars moved. Certified test. Here we go. Test, 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 test. Test, test, test. Well, hold on. Test, test, test. There we go. Test, 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 test. Walking towards the table. Test, test. Walking to the table. Almost at the table. Walking to the table. We are at the trophies. Trophies, trophies, trophies. We're at the trophies. Test, 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 test. Test, test, test. Walking away from the trophies. Hopefully that sounds better.
How soon is this starting?
Huh?
You know how soon it's starting?
No. That sounds like a fix-it.
Test, 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 test. Test, test, test. You might as well pass the word back. That's probably going to 60. That 30 is not going to be an option. It's going to be 60, okay? So with the engineering that you did, you got to see why we needed to do this kind of hard work. We're going to keep making this challenge interesting and robust. We're so excited for the senior design teams. So excited for your next steps. There's some people from last year here. So if you want to come back and hang out next year, we'd love to have you. All right, so some quick thanks, and we'll get the awards done. We'll get you on the road, okay? So thanks to you first so much to my team, the Asne staff that has been dominating and getting all this done, getting the lunch, running out, grabbing stuff for us. Really appreciate that. All the Navy judges that made this possible, right? They were out there in the water with you, helping you along. We can't brag on this gentleman too much because he's on vacation. But Dr. Russell is the reason that we're all here. We really appreciate it. And again, I really do thank everyone behind you. And I hope that when you're driving home, which I know is very far for some of you all, that you send a text to your professors, your family, everyone that was behind you to get you here. Because that was really important to get you along, this last year and probably some years before then too, okay? So take a moment to give that gratitude back to the people that got you here. And what we're going to do is do some of the special awards. They were at the reception last night. I think they're in my STEM folder, so I will be mailing them back to you. But we can clap it up and take pictures right here. Sam can come over in front with the crew, and we're going to do the special awards, and then we'll do the trophy presentations, and we'll get out of here. All right? So first and foremost, for the top video was by UCF. And come on up. Are you here? I see him moving. And there was actually a tie. I shouldn't have put a comma in that sentence. But you should take a picture. One of the top two papers tied for, I think it was 19 points. Yeah. And you were tied with, I'm not sure, is Brian here at Washington College? Brian Palmer, are you still here? I think they got up the road and with the shark hat. So, you know, they've been well given prizes of already. In addition, we had 2 judges' prizes for videos. First, we have Arkansas Tech Unmanned as a top competitor from one of our judges just thought you knocked it out of the park, and the other judge thought you did a great job. Bring it on up, get a picture. We'll get our picture. Yeah. Let's get you out in front of here.
All right, keep it going. 3, 2, 1.
Thanks. And the other, one of the other judges wanted to give a top prize to Alabama for their tremendous video work.
Roll Tide! Roll Tide!
So the next prize is all the way from scratch. It's best from the ground up, and it's actually all 3 teams from Kentucky. So Kentucky, come on up, and Dr. Hanneman, come on up. Yeah, come on up, come on up. Gotta get some photo time, some award time. Yes, ma'am.
We should probably bounce.
There's no like. I'm always wrong.
Yeah, I think I hit 5 pens.
And then every year we're asking teams to go from one team to the next to grab a drill brick, grab something like that, grab something small. And then every year some team goes way above and beyond. And so exemplary team this year was Stony Brook for getting that control against Stevens underway. All Stony Brook, come on up. Exemplary teamwork today. Worked all 3 days.
A lot of us.
Yeah. All right, so okay, maybe do those. Well, who's left in Stony Brook? They're all here. All right, let's try to squeeze in, squeeze in. We like each other, right? How about you? Throw. Yeah. For the top paper, it was also a tie. Vanderbilt and Texas A&M. Texas A&M, come on up first.
They roll Tide, we gotta go.
3, 2, 1.
Man, he once again showed up.
Vandy. So now we're going to start getting out the three sets of trophies, all right? So we have 3 different categories of classes. Thank you tremendously! In the displacement side, 3rd place was Princeton University. I don't know if you're still here at all. Yeah, come on up, 3rd place displacement. There we go. Let's
get it, go, buddy.
He built the whole boat, don't worry. Second place, displacement, Arkansas Tech University. Robin, team. Yeah, come on up. Crude. Thanks for working hard. A lot of points for working hard, all right?
Ready? 3, 2, 1.
All right, so first place, I know they already hit the road, but I think they have some team members here. Buffalo and the Bulls on Parade. Yeah, come up and grab it for them.
Yeah, but we're still accepting it for them.
Yeah. It's planning. So that'll be the last one. I'll switch spots. All right. No way. In the planing division, I'm almost certain the 3rd place team's hit the road. University of Georgia. And it was close with 1st and 2nd, but 2nd place went to Wake Forest. Think they hit the road? That's all right. And I know Stevens hit the road. Stevens came in 1st place. For the uncrewed division, which is obviously everyone who's still here. 3rd place, and just tremendous. College of the Florida Keys. That's a lot of hard work to get you all up here, get that boat around the course, and it looks so good.
Where are we going?
Right over here. 3, 2, 1. Keep going. Let me get one more.
Second place, Arkansas Tech uncrewed. There you go. First place, what was your time? 5:48. Woo! Well done. Good job.
Thank you.
Thank you. Three, two, one. We get a War Eagle. War Eagle. So, a couple serious notes, just and the important thing. If you have trash, clean it up, right? Put it in a trash bag. We have trash bags. If you need help getting out of here, I'll be the last one to leave. I'll help you get out. Okay? Before you leave, the food truck already rolled on. That speech is over. But just drive safely if you are driving today. You know, you all worked hard. You should change drivers. Don't drive dangerously. But what I talk to you all about when I stop by every school is that we're here to kind of help you along your career journey, right? And that doesn't end today. It keeps going. And as much as I wanted to give, you know, a bunch of trophies out to everyone finishing first, people win. People don't have the right day. Sometimes something snaps. Sometimes something burns up. Sometimes the wind gets you in a way that just wasn't the right moment at the right second, right? And that's on the water stuff. That's how the world is, okay? But seriously, y'all have my email address, whether it's now, whether it's down the road. Email me if I can help you get an internship or a job. You know, G, Vernova, Build Submarines, those guys will definitely help you out too. If you talk to Newport News Shipbuilding and made a connection, that's great. But don't hesitate to reach out. I talked to the upcoming group at the very end, and we're going to have a lot more events like this. And so if you are graduating, I'm so happy for you. I'm so happy you're going into a job and all that good stuff. But swing by a PEP event if we're in your neighborhood, or come back to Virginia Beach around April and watch this happen again. And if you're coming back next year, I mean, you just saw how tough the conditions can be. So there's just no amount of testing that you can do that can be too much. So get your boats in the water early and often, keep it rocking, all right? And there's a whole community that's here to support you. So when you have needs, when you need things, let me know and I'll get it to the right people. It's generally not me, but I can help connect you, okay?
Mike.
Thank you. Yes, sir.
Graduating seniors, please email Mike where you go to work. Let us know.
That's true. And if you see me creeping around on your LinkedIn page, it's nothing personal. it's to give someone some data that we sorely need. That is the way that we get evaluated. Okay? Thank you so much.
Special thanks to Mike Briscoe for bringing us all together. Mike.
Thank you all. Appreciate it.
That was good.
Dude, I'm stepping up to say that, and then you go, good job. I was like, I wasn't going to let him leave without giving him a free cheer. A lot of hard work.
I've
already loaded up the boat.
Great stuff, fellas.
Do we have boxes?
Yep.
Okay. Got it?